Hello everybody, this is Mrs. Snook with section 8.1 and our topic today is the Pythagorean Theorem. Little bit of a historical note because I do like history. Pythagoras is not the one who first discovered the Pythagorean Theorem, but we call it Pythagorean Theorem because he is the one who put his name on the paper. He actually wrote his name on the parchment. So just as a sort of note to self, put your name on your paper, that way you get credit. So Pythagorean Theorem is used to find the missing sides of a right triangle. This is important. The triangle has to be a right triangle. It does not work otherwise. A and B in our diagram are called the legs, and C is the hypotenuse. And then for any right triangle, C squared is going to equal A squared plus B squared. So let's do some examples where we're using Pythagorean's theorem to find lengths of sides. So let's take a look at number 1. We are given the legs. I'm going to call 8A and 13B. Now it doesn't matter, I could have called 8B and 13A. And then what we're looking for is the hypotenuse C. I want you to write Pythagorean's theorem every time. C squared equals A squared plus B squared. If you write this enough, you will get it memorized. What we're looking for is C. Our diagram calls that X. I'm going to plug in X for C. And then 8 for A, and 13 for B. And so literally just grab your calculators and take 8 squared plus 13 squared. I got 233, so X squared equals 233. Now just hit your square root button. So we got to take the square root of both sides to get X. So I square root my 233. And I got 15.26. It says round to the nearest tenth, so be careful of that. This is going to be 15.3. That's our first one. Let's take a look at example 3 now. This time we're given the hypotenuse, so C equals 9. I'm going to call 7 the A, and X will be the B. So C squared equals A squared plus B squared. Plug in what you know. So I'm going to put the 9 in for C squared, 7 in for A squared. B squared is what I'm solving for. So to get B squared by itself, I'm going to subtract 7 squared from both sides. So literally grab your calculator and punch in 9 squared minus 7 squared. And I got 32. So B squared equals 32. Take the square root of both sides. B is going to be 4 square root of 2. And then to round it, just punch in 4 times the square root of 2. I got 5.7. Okay, so we've done one where you're looking for a side, and one where you're looking for a hypotenuse. Now let's take a look at some more examples that are a little bit more complicated. Take a look at number 5. We have an isosceles triangle, and then X is this dashed line going down the middle there. That is a perpendicular bisector. So what it's going to do is split that bottom side into 2 equal pieces that are both measured 11, and your right triangle is right there. So I'm going to grab my highlighter and I'm just going to highlight the right triangle that I'm looking at. Now in this triangle, X is a leg and so is 11, and 24 is the hypotenuse. So C squared equals A squared plus B squared. Plug in the 24 for your C squared. A squared is 11, and I'm looking for the B squared, which is X. So that's how I'm going to set it up. And then all I got to do is, just like I did before, do 24 squared minus 11 squared. And I got x squared equals 455. And now just square root. I got 21.3. Now take a look at number 6. Check this out. We've got a trapezoid here. And this trapezoid, I can actually split that up into a rectangle and a right triangle. So because I know this piece is a rectangle, I can then say that this longer side of the trapezoid is split into two pieces. Over here, this is 5, and then 18 minus 5 is 13, and this is the same as x that I'm looking for. So now I've made myself a right triangle over here, where I've got 13x, and x are the legs, and 16 is the hypotenuse. So c squared equals a squared plus b squared. Just plug in your 16 squared equals 13 squared plus x squared. Again, I'm solving for a leg, so I'm going to do 16 squared minus 13 squared. I get 87. So x squared equals 87. And then punch my square root button, because I have to square root both sides. Second square root, whoops. I got 9.3. All right, now another kind of problem I can give you, which happens a lot with Pythagorean theorem, is word problems. And the key to these is to draw a picture and then solve. And again, we're rounding to the nearest tenth. So as you read the problem, draw a picture. This is critical. A roofer leaned a 16-foot ladder against a house. So, okay, I'm going to draw a house. Here's my house. There's its A-frame for the roof. We have a ladder. So there's my ladder. And the length of the ladder is 16 feet. So also when you draw your pictures, label. The base of the ladder is 5 feet from the house. So this part is 5 feet. How high up the house does the ladder reach? So that's x. So right here is my right triangle. Note, not drawn to scale. And I'm looking for the length x. So c squared equals a squared plus b squared. 16 squared equals 5 squared plus x squared. So do 16 squared minus 5 squared. I'm having calculator issues. 16 squared minus 5 squared. I got 231. And then just square root that, just like we've been doing. I got 15.2. Feet. Remember your units. Okay. So that's part one. Part two is using the converse of Pythagorean theorem. Now remember, converse means going backwards. And so we're going to use what we know about the sides of the triangles to determine if a triangle is a right triangle, an obtuse triangle, or an acute triangle. And here's how you're going to do it. If c squared equals a squared plus b squared, then you have a right triangle. If c squared is less than a squared plus b squared, then you have an acute triangle. So that means that all three angles are less than 90 degrees. If c squared is greater than a squared plus b squared, what you have there is an obtuse triangle. So you've got one angle that's bigger than 90 degrees. Always keep your c-squared on the left side when you do this. It makes it so much easier. Otherwise, you can get confused. And one thing I want you to watch out for is that the sum of your two smaller sides has to be greater than the third side. And let me show you what happens. If your third side, in this case 40, is longer than 16 and 22, so we've got 16 and 22 as your small sides, and then 40 is your longest side. 16 plus 22, if I add those together, I get 38. That is smaller than 40. What happens is the two sides don't meet. Your triangle does not close up. Now what if they're equal? So I have 18, 22, and 40 this time. And 18 plus 22, that equals 40. So now they're equal. You don't get a triangle. Instead, you get a straight line. So just because you're given three sides does not mean that you have a triangle. So watch out for that. All right, so let's do some example problems. Number 1, I have 3, 7, and 9 as my sides. 3 plus 7 equals 10. That's greater than 9, so I know I have a triangle. I'm okay to proceed. Now I'm going to do c squared over here, and I'm going to do a squared plus b squared over here. C squared is 9 squared. That equals 81. A squared is 3 squared plus b squared is 7 squared. So when I do 3 squared plus 7 squared, I got 58. So my c squared 81 is bigger than 58. So that means I have an obtuse triangle. Okay? Because my c squared is bigger. Now let's do number 2. And I'm just going to do a quick check. 20 plus 21. That's bigger than 29, so I'm okay to proceed. C squared is 29 squared. A squared plus b squared is 20 squared plus 21 squared. I get 841 over here, and then 29 squared is also 841. So those equal each other. That means I have a right triangle because c squared equals a squared plus b squared. Okay, now let's take a look at number 3. I'm going to do my quick check. 4 plus 11, that equals 15. That is smaller than 16. Therefore, I do not have a triangle. So I'm just going to mark not a triangle and move on. Let's do one more. I've got 22 squared. 17 plus 17 is bigger than 22, so 22 squared, that's going to equal 484. I'm going to compare that with 17 squared plus 17 squared. I got 578. Notice that's less than, so therefore I have an acute triangle. So that's it for today's lesson.